Okay, all right, so moving on. So let's look at a few more examples. So this is a bracket, right? Now this bracket is actually in the ground, and somebody said, hey, go take it out. So in what direction should you really apply the force so that you can take it out easily, right? If you knew nothing about the moment, you might say, hey, I'm just going to pull it out, right? You might want to do that, just want to pull it out, up, straight up, right? So if you do that, then you're not really taking advantage of moments to make your work easy, right? So what should you do? Well, you could apply the force in this direction, you could apply the force in the vertical direction, or lower, in a vertically downward direction, or towards the left, towards the right. So which way should you really be applying this force, right? So sure enough, let's say the force that you're applying is important, but is moment that is more important to you, right? So how do you maximize the moment of this force? So let's say you're limited by how much force you can apply, right? Because you have limited strength. So it's not like that you can apply maybe 2 metric ton of load on this bracket. So you can apply a fixed amount of force to take this bracket out. Now the only question is, which direction should you apply this force F in, right? So we already know the definition of the moment. Definition of the moment is force times perpendicular distance. So if force is a limiting factor, is not changing, is constant, then the only thing you can change is perpendicular distance, right? That's the only thing you can change. So perpendicular distance should be maximum or should be minimum? Should be maximum, right? For larger moment to happen about this point O, from where this bracket is going to come out, the perpendicular distance should be maximum, right? So what are the possible distances that you have? Well, if your force F is pointing horizontally, so if F is pointing this way, then what is the perpendicular distance? That's the line of action, and the perpendicular distance would be this, right? And how much is that? If this is L and this is theta, so then this is L cosine theta, right? So in this case, let's say this is F1, and I will call M1 as the moment of F1, would be F1 times L cosine theta. And remember, F1 is same as force F, right? Because force F is not changing. I'm just writing F1 over here to distinguish between other directions. Okay, I could also apply force in this direction, let's say F2, right? In that case, the moment would be F2 times perpendicular distance to the line of action, which is this, and that is how much? L sine theta, so that's L sine theta, right? So we have F1 times L cosine theta, F2 times L sine theta, and remember, here F1 is same as F2. I could also apply force in this direction, let's call it F3, which is along this. What is the perpendicular distance in that case? 0, because that line of action is passing through the pivot point. So in this case, M3 is actually 0, right? So if you look at any of these quantities, all of these quantities are actually less than or equal to F times L, right? They're all less than or equal to F times L. Why? Because you have sine theta and cosine theta. We know sine theta and cosine theta have values between -1 to +1, which means both of those quantities are always going to be less than F times L. And what is the maximum possible value? When theta is, in case of sine theta, when theta is pi by 2, right? In case of cosine theta, when theta is 0. So the maximum possible value is nothing but F times L, which means that you want your perpendicular distance to be L. And when would your perpendicular distance be L? If you apply a load in a direction perpendicular to L, right? That's the only situation when you can have the largest possible moment, right? So now with a little bit of knowledge of moment, you know how to take the brackets out in an efficient way, right? Okay, so that's not difficult. This is another example. This is from your textbook, right? So you have a spanner and you have a nut, and you want to compute the moment applied by these two forces, right? So you have 35 pounds over here, right? And you want to compute the moment about point O. What is the moment about point O of 35-pound load? So moment about point O is equal to, well, you draw the line of action, just extend it, and you draw the perpendicular, right? You draw the perpendicular. This is perpendicular from the point of action, which is O. And what is that distance? Given to you, 6 inches. So the answer is 35 times 6 pound-inches. And is that positive or negative? So when the question says find the moment, remember, moment is a vector quantity, so you have to give both direction as well as magnitude, not just give the magnitude part, right? So is it positive or negative? It's negative. How do we find it? Really simple. Point O is the point of rotation, so that becomes the center of your circle. You draw a circle that is tangent to the line of action, right? So that's the circle. And you're applying the force in the downward direction, which means that the circle or the wheel is going to rotate in the clockwise direction, and that means the answer is negative. Yes? Yes. Counterclockwise is positive and clockwise is negative. When did I say that? It's negative. This is clockwise, it's negative, right? Yes? Sure.
I don't understand how you explain finding perpendicular with all those forces.
Well, you want to maximize this quantity, right? F times L cosine theta. What is the maximum value of F times L cosine theta? F times L, because cosine theta has a maximum value of +1, right? Which means theta should be 0 in that quantity. So if F times L is the largest possible moment you can have, you already know the F, then perpendicular distance should be L, right? That should be this distance. And that's why the force should be pointing that way. In any other direction, it will be less than F times L.
Well, I guess because the line of action is shown there, but you drew another one. So if they ask how can you maximize the force, that's what you would do?
No, force is fixed. Force is not changing. The only thing you're trying to maximize is the perpendicular distance. And you can change the direction the force is applied. So the magnitude part of the force is fixed. What was that about? This has happened before too, right? I think it'll come back.
So to maximize the moment, we'd have to have L in the same direction as D.
Yeah, L is the D. That's the perpendicular distance, right? Yes? Oh, a good question. So why is counterclockwise positive? It's a convention, right? So what we do is we use the right-handed coordinate system. In the right-handed coordinate system, when you do I cross J, you get K hat, and K hat points upward direction. If you use a left-handed coordinate system, counterclockwise actually becomes a negative quantity, and clockwise becomes positive. So it's just a convention. We stick with right-handed coordinate system, and we do that consistently across all classes. But you may find some books that may talk about left-handed coordinate system where both of these would be flipped, essentially.